Alright, so hello everyone. Now we will continue on to the next part of our building our SAM model. So in the earlier video, I had talked about this image encoder VIT and its architecture. So if you recall, this is how we built up our image encoder architecture. Now, once the image encoder is done, we will look into this prompt encoder. Right, so we will go into this function or this class, right? So the things that this prompt encoder takes is the embedding dimension, image embedding size, input image size, masks in channel, and the activation, that is GALU. So for our case, the embed dimension is basically the prompt embed dimension, that is 256, right? So if we go here, it should be 256, and then this image embedding size, if you recall, this should be 64, because we are passing image embedding size and image embedding size, and our image embedding size is basically what, 10024 divided by 16, right? So that comes out to be 64. So that is why here it should be 64 comma 64, right? And then our input image size, that is 1024, masks in channel, that is 16, see 16, and then we have the activation, right? So what it does is, of course we are just initializing the local variables. What we do is we try to create a position embedding layer using random frequencies. So if we go inside this class, so what happens is it will create a positional encoding using random spatial frequencies. So what it will do is we basically pass number of position features. So if you see here, what we are passing is so what we are passing is 256 divided by 2, that is 128, right? So here number of position features will be 128, and if scale is none or scale is less than 0, then basically scale is set to 1, since we are not passing anything, so scale is 1 here. And then what we do is we create a positional encoding Gaussian matrix and we register it with the buffer, right? So basically what happens is 1 multiplied by a random tensor with a shape of 2 cross 128, right? So this is what happens here. And afterwards, so this is the number of point embeddings. So basically this is for how we are passing the prompts and how those prompts will get encoded, right? So since in vanilla SAM the prompts are in this manner, that we give either point prompts or box prompts or mask prompts. So this number of point embeddings will take care of the box prompts and the point prompts. So since the point prompts can be of two types, that is the positive or negative, so two prompts for the point, positive, negative, and two prompts for boxes. Basically these boxes will be the top left corner and bottom right corner. So for each of the box, it will take the top left corner and bottom right corner as the point, right? So internally, even the box prompts are executed in as a point prompt. It's just that during learning time, the meaning would be different. So basically, basically the task of these two corner points, or let's say these the 2 point embeddings corresponding to the box corners, would be to basically encircle our object. So when we provide a box, the model will learn that okay, the object is lying within this box, right? Then afterwards, so this is the number of point embeddings. So we create those number of point embeddings. So we are using an embedding layer, so it will create 4 point embeddings. 4 point embeddings, right? Each of shape what 1 cross 256, right? And these point embeddings will be stored as a list in basically this object, right? And then we are creating that as a module list. So this self dot point embeddings will have all of these 4 point embedding layers as a module, right? And then of course for a not a point embedding also we have to give um, because you know in the SAM it also works when you do not give any points, right? So without points also there should be some embedding that has to be learned, right? Now afterwards, here basically what we are doing is we calculate the mask input size. So mask input size will be this is our image embedding size, and our image embedding size is what, 64. So this is 64 comma 64, right? So here our mask input size will be 256 256, right? And then for mask prompts, we have to create a sequential layer as well, so that the masks are also processed. So in this mask down scaling layer, what happens is we have a convolution layer with input channel as 1 and output channel as what? Mask and chance is 6, so that should be 4, and rest of the things kernel size stride. So basically here we are doing a down sampling, right? Because we have a kernel size of 2, stride of 2, and then layer norm, and then activation, that is GALU, and then again here another convolution layer with the input shape of 4, input channel as 4 and output channel as 16, right? And another activation layer, and here input channel will be 16 and output channel is 256. So output channel is 256 because we have to match the channel of our image embeddings, right? And then we have no mask embedding as well, in case we are not providing any mask prompts. So this is also 1 cross 256, right? So this is basically how our prompt encoder looks like. I'll show the forward pass, right? So what happens is when we do forward pass, so during forward pass, what it will expect is points, boxes, and masks, right? So in the forward pass of our prompt encoder, if I show you, so in sam.py, so in sam.py, after getting the image embeddings, when we do forward pass for prompt encoder, we just pass the points, boxes, and masks. So in the prompt encoder itself, there is no inclusion of your image embeddings or image, or of course ground masks, right? So in prompt encoder, you just pass the points, boxes, and masks, and these will get encoded, right? So here what happens is you pass the points, and of course these points has to be between 0 to 1023, right? Pixel positions, because the input of your image encoder is resized to 1024, right? So these points should not lie after 1024, right? So what happens is in the forward pass we will get the batch size. So as for now, let's suppose it's 1, or let's just say B, right? So basically here what will happen is it will create a tensor with the same batch, and here 0 means that this will be filled later, right? So right now it won't contain anything, but this will get filled later, right? And in case you have passed any point prompt, so we will extract the coordinates and labels. So these points will basically have the point coordinates as well as labels. So let's say something like x1 comma y1, something like this, x1 comma y1, and the label, let's say this let's say this coordinate represents a positive prompt, then the label would be 1. For negative prompt, the label would be 0, right? So we are extracting that. So at this point we will extract the coordinates and labels, and then we will embed those points, right? So for embedding those points, what we do is we have embed points function. Inside that we pass the coordinates, labels, and pad, that is if boxes is none, then we will pad, right? So inside this what happens is we shift all the points with by adding 0.5, right? And then if the pad is turned on, in our case, if the box is not given, then this area will execute, otherwise it won't. So here what happens is basically we create a padding point. So here the shape would be B cross 1 cross 2, and all of them will be filled with 0, right? And similarly for labels, we will have a shape of B cross 1 B cross 1, and these will be filled with -1, right? So basically if we are padding the points, the padded points should be 0 and the labels would be -1. And then as for the points, this will have a shape of, we are concatenating the points with padding points, right? So the shape will become V cross n plus 1 cross 2. So this n is basically how many point prompts we are passing, right? And similarly the labels will become V cross n plus 1, right? So afterwards once this is done, what we will do is we have a position encoding layer, right? So we will pass these points and the input image size, and we will do the forward pass, right? So what happens is, right, so what happens inside that thing is, what we do is we create a clone of it. So this coordinates will also have a shape of b cross n plus 1 cross 2, and then we are basically normalizing it, right? Normalizing the values between 0 to 1 by dividing with the, you know, by dividing with the height and width of the image size. So these are basically chords, and zeroth, I mean x values, chords x values are divided by 64, and here chords y values are divided by 64, right? So at this point these chords are normalized with values between 0 to 1. So again we do self dot of p encoding. So that would mean we are calling this function. So here what happens is it will have the shape of same b cross n plus 1 cross 2, and basically what we are doing is we are multiplying each of the values of our you know, this normalized these normalized values with 2. So if the maximum value is if, let's say, if max of chords is equal to something like 0.99. Why 0.99? Because inside this coordinates, sorry, here it should be 1024. So divided by 1024, right? Because image size is 1024. So what happens is inside this chords the values are between 0 to 1023. So if you're dividing it from 1024, so of course that value is lesser than 1, right? So if the maximum value is, let's suppose, 0.199, so we just multiplied it by 2 and subtract 1 from it. So this is just to make sure that values get between minus 1 to 1, minus 1 to 1, right? So why minus 1 to 1? Because if the smaller value, if the mean chords is something like 0, right? So it will become 2 into 0 minus 1, that would be minus 1, right? And then what we do here is we multiplied this chords that has a shape of b cross n plus 1 cross 2, and we do a matrix multiplication with self dot positional encoding Gaussian matrix. So if you recall, so the shape of the self dot positional encoding Gaussian matrix is 2 cross 128. So this would give us what? This would give us a shape of b cross n plus 1 cross 128, right? So now what we do is we multiply all of these values with 2 into pi, right? So this will become 2 multiplied by pi multiplied by all of these values, right? And the shape of b cross n plus 1 cross 128, right? So here what happens is at this point, then we do sine, we apply the sine function and cosine function on these chords, and then we concatenate those with the in the dimension of minus 1. So this would return b cross n plus 1 cross 256, right? So this is how we are going to encode our point prompts, right? So that will get returned to our embed points. So here point embeddings. So now what shape it will have is b cross n plus 1 cross 256, right? Because this is basically what we are returning, b cross n plus 1 cross 256. Now of course if this pad is not enabled, otherwise b cross n cross 256, right? And then what happens is right, so in this point embedding, wherever the label is set to minus 1, so we set those values to 0, and at those points we add the not point embedding weights, right? And wherever the label is 0, that would mean we are basically passing negative prompts, right? Negative prompts. So for negative prompts we add the point embedding 0. So in the point embeddings list, the 0th point embedding will represent the weights of negative prompts, weights corresponding to negative prompts. And if the labels is 1 in this point embedding, so we will add the point embeddings of the first object, right? Or first embedding layer, right? So this is how we are going to encode our points. So at this point shape of our point embedding will become b cross n plus 1, or let's say just n, b cross n cross 256, and then we will concatenate with the sparse embeddings. So the shape of this sparse embedding will become b cross n cross 256, right? Similarly, if the box prompt is also given, then we will have to embed the boxes as well. So how this is done is, if you see, uh, the boxes, okay, so here the shape is not mentioned. So basically the boxes should have a shape of v cross 4, right? 4, because for the two corners we will have we will have the x1 comma y1 comma x2 comma y2, right? So in the embed boxes function, we get the boxes, we shift the center of we shift the values to the center of pixel, and then we reshape it. So this coordinates will become what? This will basically become 1 cross 2 cross 2, right? Because this box had a shape of what? B cross 4. So it should be like 1, or let's say b. So b cross 2 cross 2. So basically what is happening is it will separate the x and y values. So this will basically become something like x1 comma y1 and x2 comma y2, right? Now we again call this position encoding layer, and since this is basically now in a coordinate shape, so we call the forward with coordinates function. We pass the coordinates and we pass the input image size. So again the same things will happen. So the coordinates will get cloned. So here the shape for boxes will be b cross 2 cross 2, right? And here again the values will get you know the values will get normalized between 0 and 1. And similarly this function will be called, and we will multiply this position encoding Gaussian matrix. So for boxes it will generate something like a b cross 2 cross 128, and here for boxes it will generate something like b cross 2 cross 256, right? So that would mean this corner embedding will have a shape of b cross 2 cross 256, right? And then what we do is we will add the point embeddings for the top left and bottom right points. So this is how we are going to do it, right? So here this box sorry so here this box embeddings will have a shape of b cross 2 cross 256. We again concatenate it. So basically what it will give us is, we concatenate it with the sparse embeddings that earlier had a shape of b cross n cross 256. So it should now have a shape of b cross uh, n plus 2 cross 256, right? Now if masks is also given, so the embed masks function will get called, and it will basically just downscale it using this mask downscaling layer, and the output mask embedding will get returned. So we are also providing any mask prompt input. So in SAM the mask prompt input has a shape of 256 cross 256. If we also have to give the batch dimension, then it would be something like b cross 1 cross 256 256, right? So after going through the first convolution layer, it will become something like v cross 128 128, and then after passing through the second convolution layer, it would become something like this, right? And so here the shape, output shape would be this, b cross 256 cross 64 cross 64, right? So here it should be b cross 256 cross 256 cross 64 cross 64, right? So if the mask prompt is also given, then embeddings becomes this. If the mask prompt is not given, then it will use the no mask embed weights, and that will get reshaped to 256 cross 1 cross 1, and then we will expand that to the shape, right? And then basically here we return sparse embeddings having a shape of this, and the dense embeddings having a shape of this. So this is basically how the whole prompt encoder works. And then this sparse embeddings and this embeddings is returned to your sam.py, and then these will be used in your mask decoder as an input. So we basically pass the image embeddings, and then we pass the positional encoding layer, and then we pass the sparse embeddings and the dense prompt embeddings that we get from prompt encoder, and this is just a flag to ask whether we want multi-mask output or not. So this is how the prompt encoder works. This is everything about the prompt encoder. So if I have to draw a block diagram for the prompt encoder, maybe what I can do is right, so points in shape of p cross n cross 2, boxes in shape of b cross 4, and then masks shape of b cross 1 cross 256 cross 256. Right. So these are the things that go inside your prompt encoder, and then basically we find out the batch size. We create a sparse embedding, something like this. Uh, we create a sparse embedding, right? So we create sparse embeddings. We fill it with nothing, and then we pass the points to your embed points. So basically, what will happen is, not this one. How do I represent a layer? Let's just use this one. Embed points. Similarly, I will use 4 embed boxes and 4 masks as well, right? So embed points, embed boxes, and embed masks. So the output of our embed points is a tensor with shape of b cross n cross 256, right? So it would be something like, and this is named as point embeddings. So the point embeddings has a shape of b cross n cross 256, right? And these two will get concatenated. So this will, maybe I should add it somewhere here. Right. So this point embedding and the sparse embeddings will get concatenated, and it will remain the same shape, the shape of this one. Now we will also embed the boxes. So we embed the boxes similarly, and from that what we get is box embeddings, right? And this box embeddings will have a shape of something like b cross 2 cross 256, right? B cross 2 cross 256, and then this is also concatenated. So this will get concatenated as well, and at this point of time the shape of sparse embeddings will become b cross n plus 2 cross 256, right? And if we have our masks, or if we do not have it, then still we will get mask embeddings or dense embeddings, right? So this dense embeddings will have a shape of b cross 256 cross 64 cross 64. So these are the outputs of our prompt encoder. If you want to get some color, then we can give it like this. Cool. So this is how your prompt encoder will look like. In next video, I will talk about the mask decoder. That will take some more time, because it has a lot of stuffs like your transformers, your two-way transformer, and then how it decodes everything together and produces masks. So I think in the next video I will talk about it. But for now, I think this prompt encoder is done. Thanks for watching.